Okay, let's wait maybe 1 minute. See. Okay, maybe I can get started. Well, I hope it doesn't come as a surprise that I'm going to give this speech in English. And my name is Federico Tomassetti. I run a company specialized in language engineering. One of the things we do is to take code bases written in old languages and translate them to modern languages. And so I will explain the technique we use to achieve this. But first of all, I would like to talk about the problem of legacy modernization. And I assume all of us are developers, so we are interested mainly in technology. But I think that legacy modernization is a problem that is not just about technology. It's a problem that has an effect on business continuity, because when we have a company that maybe have 30, 50 years of history as a software written in a legacy language, and they run into problem because of that, this can affect this business and can eventually lead this business not to be competitive anymore and to run out of business. And therefore, this, of course, affect people that are somehow connected to the business, employees of this business, suppliers, and or people that benefit from what this business is producing. So I think it's important to consider not only the technological aspects, but the effect of this. And this may be a little bit abstract, so let's try to think about one story, a story of a company based in Rhône-Alpes. Well, I used to live in Lyon, so I wanted to get an example from the area. Maybe a company that is producing components for textile machinery. These companies in the 90s decided they want to start using these computers and take advantage of them, and so they write some software to drive all their processes, what we call an ERP. At the time, a perfectly fine solution would have been to buy an IBM i S400 that is not a mainframe, it's not exactly one personal computer, it's something in between, let's say, and to use the typical language that you were using on those machines, that was RPG. And so they write their software, they use it to run their entire business, to verify what they have in the warehouse, to track orders that they receive from their clients, orders they send to suppliers, prepare invoices, whatever. So they drive the entire organization thanks to this software written in RPG. Good. But then 30 years passed, you see the guy is still at work, he didn't have the time to change his shirt, he's a very disciplined worker. And the problem is that the company kept investing, kept maybe modernizing their hardware, and tried to stay competitive in a world where we know it's not easy to stay competitive. Now there are competitors from Asia, and you know, they're fighting hard to keep this factory where it is. But they have a challenge because they're using RPG. And so we will see exactly the specific challenges. But they decide to hire an enthusiastic IT director, or maybe I don't know what kind of substances he's using. And so the guy decides to migrate to Python. And what are the effects? So what will be the consequences? One first consequence is that they could stop using these IBM proprietary hardware. They could start using random machines like this one, they could rent a cheap Linux server, they could move to the cloud, they could do whatever. But until they're using RPG, they cannot do that, because RPG only runs on these proprietary expensive machines. The second difference, okay, that's not really readable, but the second difference is that there are way more Python developers than RPG developers. Now, you cannot read that but basically I search on LinkedIn for RPG developer in Auvergne-Rhône-Alpes, and there are 336. Python developers, there are 49,000. So, for each RPG developer, you have 145 Python developers. So, it's easy to imagine that it's much, much easier to hire Python developers than RPG developers. And also, we can assume that it's easier to find good Python developers than RPG developers. Unless all the 336 RPG developers are all brilliant, but you know, that would be statistically difficult. Another big difference, and this is something that maybe if we are using modern languages, we take it for granted, but for modern languages there is a crazy amount of components we can use. Maybe you're used to JavaScript and you have NPM, and maybe you're used to Java and you have Maven Central. In the case of Python, there is PyPy with something like 700,000 projects, frameworks, libraries. Not all of them will be good, but still you have an incredibly availability of components that you can use to write your software. In RPG, there are 0. So that's, you know, a different level of facility. And then there is productivity. Now, this is a little more vague. There are no concrete answers, but we can imagine concrete numbers to support this. But from what I know, just implementing small changes in RPG is a little more cumbersome. So we can imagine the scenario where an executive want to maybe run some scenarios to consider different options, because maybe they need to assess if they want to buy a new machine, maybe they want to assess if to launch a new service, and they need to get some numbers and run some calculation and have material to support their decision. Doing that in RPG would be very difficult, while if they were moving to Python, putting scripts together, writing a small Python notebook, and assess this scenario and provide an answer to the executive that asks for that will be much, much easier. So we could provide answers in a matter of hours instead of weeks. And so our business will be able to make decisions to consider options much more easily. So this is just an example. This is an example of a company that wants to migrate from RPG to Python. But this is not the only example. Maybe you don't care at all about RPG and you never heard about it. That's perfectly fine. Maybe your life is better because of this. But the same principle applies to other problems companies have. There are companies out there that have software that is still written in Visual Basic 6. Or there are companies that adopted one of these languages that were very popular for a very short period, this 4GL system like Progress, Informix, PowerBuilder. Or maybe there are companies using SAS that nowadays would like to move to maybe PySpark. Okay, COBOL maybe is the one that you may have heard. So there are, of course, companies that have COBOL and may want to migrate to Java, C#, whatever. But at this stage, there are also companies that maybe have their software written in Java, but maybe they are using a framework that was dismissed 15 years ago, and they would like to migrate. And so these are all cases in which being stuck to an old language has an effect on your productivity. So we've seen the problem. Now, what do we do about that? How do we solve the problem of taking a piece of code written in an old language and automatically migrate it to a modern language? Now, this is a piece of RPG code. It may look a very weird language. It was created in 1959, so I guess none of you were born. This piece of language basically, this snippet basically declare two variables, then assign some values to those variables, and then compare them and say if the amount is greater than the threshold, then we call a certain function. So weird syntax, but very easy logic. Now, if we were to translate this, and we were to translate it into Python, so in this case, we import a decimal that we use to represent a number with absolute precision. Then we assign 100 to threshold, decimal of 125.75 to amount, and then we have a simple if with a comparison. So the code is simple, but how do we do that automatically? The first step is to recognizing the structure, and that is the job of a parser. So we will need to use a parser to go over this code and recognize the different elements. And so a parser will recognize that the first line is a declaration of something called amount, and is a variable of type 7p2 that stands for a value of 7 digits, 2 of which are decimal, and so 5 of which are integer, because in RPG you need to specify how many digits you want to use. Then you have another declaration of a variable called threshold. In this case is a variable, an integer variable with just 5 digits. And recognizing the structure in our case means okay, that's very hard to read. So either you have incredibly good eye or you will not understand anything of this image, but yeah. Basically, in this case, what I was supposed to show here is an abstract syntax tree. So a little piece of tree that contains the information that we have in a code in a structured way. And so basically here I'm saying, oh, let me read it on my screen. I have here a standalone field. Inside the standalone field there is a node of type packed decimal type. So this little node within these bigger nodes indicate this part of the wall declaration. So recognizing the structure means creating this model organized as a tree. Similar model for another declaration, and so on. I go on and analyze each instruction, and I construct the corresponding model, obtaining an entire tree representing the information present in the original code, but structured in a way that is easier to process. Then I have an if statement. You may notice that in RPG there is this weird constructs that basically combine an if with a comparison. So this is if greater than. So yes, in this case, if the amount is greater than the threshold, then I will execute the body of the if. In this case, I will call a certain procedure. Now, the challenge here is in translating the statements, these assignments. In this case, I want to translate threshold equal 100 as threshold equal 100 in Python, so that stays the same. However, I want to translate amount equal 125.75 as amount equal decimal of 125.75. Now, the problem that I have is this, that I want to translate these two assignments, and if I look at them, and only at them, they have the same structure. So how do I know that I need to translate them differently? In this case, I know because, or I need to find out this in order to decide how to translate it. I need to connect this assignment to the corresponding declaration. And then when I see that this assignment corresponds to something of type 7p2, that means a number with decimal digits, then in Python I want to represent that as using the decimal class to have absolute precision, so it affects rounding and stuff like that. Now, I cannot figure out that this is of type 7p2 by looking at this structure. I need to connect it to that. And this connection is what we call symbol resolution. Once I connect it to the declaration, I can read the type. Now, if you couldn't read that, you definitely cannot read this. But basically, what I'm trying to show is that here, I had my model of my assignments, and here I had one connection, one reference, and here I say the name, in this case threshold, correspond or is connected or indicates another part of the model with this ID. So is essentially a link, a connection to the declaration, so that when I'm looking at the assignment, I can find this link, jump to the declaration, read the type, and decide, okay, it's an integer, I don't need to add a decimal, it's a pack decimal with decimal digits, so I need to add decimal. So I need to add these connections. And then I have another challenge. And here is a challenge connected to GoTo's. I guess none of you have used GoTo's. But GoTo's were instructions that were used in the first programming languages people created, and eventually they figured out they were not a great idea. But basically, when I have a GoTo, I arrive to the GoTo and I jump and continue the execution from that point. In this case, I would execute eval, execute display, find a GoTo to loop. I will go here and continue executing from there. Eventually, people figure out that this leads to code that is extremely difficult to understand and follow, and so modern languages don't have the GoTo. The problem is, if I have a program written in RPG that uses the GoTo statements, how the hell do I translate the GoTo statement into Python? There is no equivalent. So in this case, I need to do something. Okay, here I'm just showing the connection between the GoTo's and the corresponding label. I need to do what is called control flow analysis. So this is a visual representation, but to do that automatically, I will build a similar model in code, and I will say, okay, I start from here. This is just a label, a point that I can jump to. Then I execute the instruction, arrive to an if. If the counter is greater than 3, then I go there where there is a GoTo that makes me go outside the loop. If the counter is not greater than 3, then I do something, and then I jump to the start of the loop, and I continue like this until eventually counter will be greater than 3 and I will jump out of the loop. Now, here I have exactly a loop, and so I can notice that some GoTo's are inside the loop and some GoTo's are outside the loop. And so I can figure out that I can translate some GoTo's as breaks in Python and some GoTo's as continuous in Python, instructions that are available. So I cannot say I will translate all the GoTo's in a certain way. I need to figure out how they're used, and depending on how they're used, translating them as breaks or continuous. And so once I figure out that, I add some extra piece of information, some markers, we call them annotations. I add them, they have a different background, if you could read the slide. I added this additional piece of information to the GoTo's that I had, and so I mark some of them as a break and some of them as continue-like GoTo. So GoTo's that plays the role of a continue. So until now, we recognized the structure of the code and we created the first version of our model, of our abstract syntax tree. Then we figured out that some names were used to indicate connections or links to other nodes, and so we added this connection through the process that is called symbol resolution. And then we continue to analyze, and this analysis may differ depending on what kind of translation we are going to do. If we are translating for our RPG, a typical analysis that we want to do is control flow analysis to recognize the roles of gotos. And so we, based on this analysis, add additional markers into my AST. That so started as very simple, then I add connections, then I add markers, and becomes more and more complex, contains more and more information. And these are the first steps of our migration pipeline. Now, let's see if there is... now, at least you can read this step. This is probably the only things that you can read, so I'm very happy that I put it there. But right now I'm writing a simple script that execute the different steps of our migration pipeline and produce the different stages. Initially, just the first model without symbol resolution, then we add symbol resolution, then we add analysis. Now, I created also a small web application to look at one of these files. These files are the output of each step that I ran very quickly before. So if I see the output of the first step, after I just created the initial structure, the initial AST of my code, I have something like this. But maybe here, can I zoom? Okay, so I have, in this case, a file that contains a compilation unit. Compilation unit means everything contained into a file. Then I have, for example, my standalone field, which is pack decimal type, where I can figure out that there are 2 decimal digits, 5 total digits. I can figure out that this was contained on line 12, and so on. Somewhere I should have also my assignment. And before I perform symbol resolution, I just know that in my assignment I'm referring to something called threshold. I just don't know what threshold means in this context. Now, this example is obvious. I have just one declaration called threshold. But let's imagine the case of Java, where you can where a name can refer to a parameter, to a local variable, to a field that maybe you have inherit. It's not always that easy to figure out what is the corresponding declaration. So if I now load the next step after I perform symbol resolution, now I should see that now I have recognized the threshold correspond to a certain declaration, and I can navigate to it, jump to it, because it contains the ID of the node representing my definition, and so I can read the integer type and use it to decide how to translate my code. Finally, if I look at the example after I perform the control flow analysis, and I look at my gotos, like this one, I can see the initial structure that I recognized just by looking at the code. Originally, I recognized that there was a goto connecting to a label called AND-L for AND label. After the analysis, I added an additional marker, an additional annotation, that is this one that says, oh, I analyze how the control flow runs, and so I know that this is a break-like goto. And similarly below, I have a continue-like goto. So the idea is that we add information a little bit at the time. Now, adding information is the first part of the job. So creating a detailed model of the original code, so figure out things about the original code and put them in an order structure that we call abstract syntax tree. But then we need to use this information to actually generate the target code. Now, a naive approach could say, okay, I have this tree, I could run a visitor over this tree. When I recognize a goto with the marker break like goto, I just print a break on the output and then I save it to a Python file. This is an approach that doesn't work very well because typically we need to do a bunch of things when generating code. Yes, we need to decide how to translate each single element, but we also need to produce code that is well indented and well formatted. We may want to perform simplification and optimizations. We have to consider imports, and imports typically are put in front, so you cannot generate a piece of code and then say, oh, now I need to go back and add an import, or at least you cannot do that super easily. So there are a lot of things to do to actually generate the code, and this is why typically this problem is split into a set of sub-problems. First, I will create another abstract syntax tree representing the code that I want to generate so that I can work on it, refine it, and then only when it's perfect, I will go over it and produce the target code. So it's a sort of divide et impera problem because, yes, I have many tasks to do, so I divide it into steps. Now, I will go a little bit quickly over the steps, but the first thing is to create, given the model that we have built before through parsing, resolving symbols, analyzing, we have now this nice model. Now we look at each piece and we say, for example, when I encounter a piece of type goto statement and I see that is annotated as a break, then I will create in a temporary model representing the Python code that I want to produce, I will create a node of type break statement. If I find out that this goto is marked as a continue, I will create a node representing a continue statement. If it's neither a break or a continue, for now I don't know what to do, so I will just explode. Now, the problem is that now on this model, I may want to look at it and find certain structure that I want to optimize to make the code more idiomatic in the target language. For example, in Python, you could write this: if a certain condition is true, assign A to X, otherwise assign B to X. Technically, this is valid Python code, but a Python developer, I'm told, will write something like this. So, using this specific form that is typical of Python. So, what I want to do, now that I have a model representing the RPG code, is looking for this structure and change them into this structure. And so this is one example of optimization, but I can do many others. And only when the model of my Python code is perfect, then I will go at the different elements and just print the different elements. So I postpone the printing after the optimization. And so some rules could be very simple, because when I say when in my model I encounter the node representing a pass statement, I will just write pass. a break, I will just write break, and a continue, I will just write continue. Of course, there are instruction more complicated where I need to change the indentation level, write some instructions, the body, then the indent. So some things are a little more tricky, but this is essentially what I need to do to print the code. And now we can see the pipeline, because essentially we start with some initial files, for example RPG, but also other supporting files that are used together with RPG. Like when you have a web application, you typically have maybe HTML file, CSS file, JavaScript file, so you have a bunch of files written in different languages. The same is for RPG application. We look at all these files, we load into the system, we parse them and create the initial model, we resolve the symbol, we do the analysis, we create the first version of the model of the Python code, we do some optimization, and then we generate the Python code, and then these steps, it means just save it into disk. So we went through different steps, and at each step we produce one file that we could, for example, inspect using the web application that I demonstrated before. So we have a very complex problem that we can split in much simpler problems and look at the intermediate results. These intermediate files are defined using a standard that has been created by a bunch of nerds like myself. That is, this standard is called LineWeb, is available at lineweb.io. And there are libraries to create these intermediate files or read them from Java, Kotlin, TypeScript, C#, and Python. Why is it important to have libraries to play with these files from multiple languages? Because, for example, we write typically our migration using Kotlin, but then we can open this file in TypeScript to show them in the browser, as I did it before. Or, for example, we create a dashboard in Python, like we did in this case, because typically we start a migration project. At the beginning, we cannot translate anything. After 1 week, we can translate a little bit. After 2 weeks, a little bit more. And the client keeps asking where we are with the migration. And then we can look at these files and say, oh, you know, you gave us 5,000 files. For now, we can translate 3. And the day after, we can translate 4 and 5 and 6 and so on. And we can present this data using, for example, a dashboard written in Python. It was very beautiful. It's a pity you cannot read it. So yes, through LionWeb means that we can write our very complex solution using different languages, and I think it's an advantage. And in case you're interested in this topic, I wrote an article for InfoQ about this approach where I go in a little more details. And I want just to share a few takeaways that I think that is important, that one advantage of this approach is that we break a complex problem into small steps and we can look into the result of each step. This approach is very similar to what we will do if we needed to build a compiler, and some of the steps are exactly the same, for example, parsing and symbol resolution. And because we use LineWeb and open standards, we have the advantage that we can read these intermediate files from different languages, write tests against them, debug them, and validate them. Now, this problem is not completely solved in the sense that this approach works and works well. We can translate code bases of millions of lines of code, but there are things we are not yet very happy about. The first one is that it's very difficult to demonstrate to the client that the migrated application does exactly the same things as the original application. There are techniques to do that, but there are not great techniques that are easier to implement and makes the client super happy. So this is, I think, the major problem we have as a community. Another problem is that it's extremely difficult to do a nice migration from when changing the paradigm. So if you want to migrate, like we tried to do for a project, from COBOL to Elixir, a functional language, that is extremely hard because the logic in which the code is organized is totally different. And then we have also the problem of documenting the generated code, but it's the third one because it's maybe the least relevant for now. So you can find this article online. There are a lot of articles on my blog on this topic. And if you want, I suggest you to look at lionweb.io, where you can read more about this specification and what it can be used for. And so that's it. So thank you. And